Established in 1920 with the name Teknische Hogeschool Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's one-century existence. The establishment of this long-established institution is recorded in history as the founding of Indonesian technical higher education and the pioneer in the advancement of science and technology in Indonesia. Located in Bandung, West Java, Indonesia, precisely on Ganesha Street number 10, ITB currently has 12 faculties, 29 undergraduate programs, 52 master's programs, 26 doctoral programs, and 2 professional programs. Other than the campus site located in Ganesha, ITB's campuses are also located in Jatinangor and Cirebon. 39 programs have been internationally accredited from accreditation boards around the world, namely from the United States of America, ASEAN, Germany, Japan, United Kingdom, South Korea, and the number of accredited programs is expected to increase in the near future. ITB has been developing its cutting-edge research through the 102 research groups from 12 faculties and schools, 24 centers, 7 research centers, and 5 centers of excellence. To date, ITB has also established 104 startups, 315 intellectual property rights, and 137 innovations. In the spirit of In Harmonia Progressio, ITB alumni have worked and excelled in various fields and sectors. For instance, Insinyur Soekarno as the first President of the Republic of Indonesia, B.J. Habibie as the 3rd President, Iskandar Ali Shahbana as the father of the communication system in Indonesia.
Institut Teknologi Bandung is an adaptive learning organization. In our over 100-year journey, ITB has a long-standing as the leader in advancing science, technology, art, and social and humanities as well. ITB is striving to play a significant role in solving Indonesia's challenges while improving its capacity to compete globally. The alumni are our pride, who continue to share our values and significant contribution to the nation's development. To continue our tradition, we will always preserve a campus with academic atmosphere that is open to new ideas and experiences, critical and visionary thoughts, accompanied by attitudes that uphold academic freedom in scientific and cultural diversity. We are keen on continuously improving the quality of education, research, and community services, progressing in harmony, in harmonia progressio.
Distinguished ladies and gentlemen, the opening ceremony for the 4th International Conference on Sustainable Infrastructure and Built Environment 2022 is about to start. During the conference, we would like to kindly request you to open your cameras, mute the microphone, and use headsets or earphones for a better sound quality. Thank you. The conference Zoom virtual background file will be available in the chat column. Kindly download and use the available virtual background and rename the Zoom account with the format institution_full name. In addition, please kindly fill in the attendance form provided by the committee in the chat column. Thank you. Ladies and gentlemen, kindly take your seats as the opening ceremony will commence shortly. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Peace be upon you. Distinguished ladies and gentlemen, allow me to extend our warmest greetings to our honorable guests and speakers. Our very warm welcome to Her Excellency, Rector of Institut Teknologi Bandung, Professor Reini Wirahadikusuma, PhD, His Excellency, Dean of Faculty of Civil and Environmental Engineering, Institut Teknologi Bandung, Insinyur Edwan Cardena, PhD, Her Excellency, the Chair of the Committee, Insinyur Indah Rahmatiah Siti Salami, MSc, PhD, our honorable keynote speakers, His Excellency, Mr. Luhut Binsar Panjaitan, MPA, Coordinating Minister of Maritime Affairs and Investment, Professor Satoshi Okabe from Hokkaido University, Professor Louis Ke from the National Taiwan University, honorable partners of the conference, our honorable guests, professors, all delegates, presenters, participants, and all conference committee. A very good morning and welcome to the first day of the 4th International Conference on Sustainable Infrastructure and Built Environment 2022. First of all, let us thank God the Almighty who has given us the opportunity to attend this online conference in good health. The 4th International Conference on Sustainable Infrastructure and Built Environment will be held in 2 days, 8th and 9th March 2022. Today, 8th of March 2022, we will be participating in the first day of the 4th International Conference on Sustainable Infrastructure and Built Environment 2022. An opportunity for engineers, researchers, and policymakers to discuss and learn more about the newest development in the implementation of sustainability in infrastructure and to encourage building resilience in the built environment in the present and in the future. During the plenary session for today, we will be listening to the 3 excellent keynote speakers, Mr. Luhut Binsar Panjaitan, MPA, Coordinating Minister of Maritime Affairs and Investment, Professor Satoshi Okabe from Hokkaido University, and Professor Louis Ke from the National Taiwan University. On the second day, we invite all attendees to listen to our excellent keynote speakers, Dr. Insinyur M. Basuki Hadi Mulyono, MSc, Minister of Public Works and Public Housing, and Dr. Fuad Bendi Merat, Executive Director of Earthquake Megacity Initiative. I am Rizvika Ramita Salim, and it is a great honor for me to be your Master of Ceremony for the 2 days of the International Conference. At the start of our opening ceremony, we will listen to the national anthem of the Republic of Indonesia, presented by Institut Teknologi Bandung Choir. We would like to request you all to raise. Ladies and gentlemen, please be seated. Thank you. We will start the opening ceremony for today's event by listening to the committee report presented by the chair of the committee, Insinyur Indah Rahmatiah Siti Salami, MSc, PhD. Insinyur Indah Rahmatiah Siti Salami, MSc, PhD, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, the Honorable Rector of Institut Teknologi Bandung, Profesor Reni Wirahadikusuma, the Honorable Dean of the Faculty of Civil and Environmental Engineering, Dr. Edwan Cardena, the Honorable Keynote and Invited Speaker, the Honorable Invited Guests, and distinguished participants, ladies and gentlemen. Welcome to the 4th International Conference of Sustainable Infrastructure and Built Environment, SIBE 2022. This conference is organized by the Faculty of Civil and Environmental Engineering, Institut Teknologi Bandung, and once every 4 years, starting in 2009. And today's conference is the 4th in the series of the International Conference of SIBE. It is hoped that in the future, SIBE will always become the platform where scientists and practitioners meet and discuss science, innovation, and solutions for sustainable infrastructure and built environment. For this 4th SIBE 2022, it is great honor to welcome our distinguished keynote and invited speakers, Bapak Luhut Binsar Panjaitan, the Coordinator Minister of Maritime and Investment of Republic Indonesia, Bapak Dr. Basuki Hadi Mulyono, the Minister of Public Works and Housing of the Republic Indonesia, Professor Satoshi Okabe from Hokkaido University, Dr. Fuad Bendimirat from the Executive Director of Earthquake Megacities Initiative, Professor Louis Ke from National Taiwan University, Professor Michael Templeton from Imperial College London, Professor Tadashi Yamada from Kyoto University, and of course, Bapak Abdul Malik Sadat from the Ministry of National Development Planning of the Republic of Indonesia. The activity of the 4th SIBE 2022 has been started last year when we have a webinar with the title of Imagining of a Sustainable and Resilient ASEAN Cities 2040, an Engineering Perspective, on the 13th of November 2021, with expert speakers in their field, which are Bu Weni Maulina from the MRT Jakarta, Venta Kata Chalam, PhD, Director of Research Strategy and Innovation of Economic Research Institute for ASEAN and East Asia, Professor Koji Ichi from Kansai University, Mr. Salendra Ram from Transport Astarian Society. In this main international conference today, we will present 8 sub-themes with 144 presenters coming from various institutions in Indonesia and abroad, covering the subject of civil, ocean, and environmental engineering. After the main seminar, we will also have another side event, a half-day webinar on the 10th of March 2020 with the title Improving Accessibility of the Safe Drinking Water in Southeast Asia to Achieve the SDGs. This webinar is a collaboration between the Faculty of Civil and Environmental Engineering, specifically with the Water and Waste Engineering Research Group and the International Water Association. Therefore, I would like to convey our gratitude to all the authors, the participants, and attendees for joining this conference to share and discuss research findings and experience in the subject. Although this event will be placed online due to the pandemic situation, I believe that it will provide a forum for discussing and evaluating cutting-edge ideas, innovative technology policies, and new perspectives for sustainable infrastructure and built environment. Additionally, we would like to ask all attendees to consider the possibility to expand the collaboration and network between us or among us, practitioners and scholars in solving infrastructure and built environment. I hope this event also will be repeated in 2026 to foster scientific collaboration and enhance our partnership. We're also very grateful for the support provided by PT Diva Mahakarya, Harita Nickel, Adikarya, Modern Widya Technical, PT Hutama Karya, Brantas Adipraya, Pitako Mitra Persada, Delta Sistek Indonesia, Penta Arsitektur, Nindya Karya, Nur Strait Engineering, Nippon Koi, Adi Asset, Suropati Hydro Energy, and Jasa Marga Toll Road Maintenance. We would like to thank you all for all active engagement in this conference. Despite there being some shortcomings in this conference, we apologize for that, but please enjoy the conference and thank you again for your participation. Wassalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Thank you, Insinyur Indah Rahmatiah Siti Salami, MSc PhD, for the committee report. Ladies and gentlemen, following our next agenda, we would like to invite the Dean of Faculty of Civil and Environmental Engineering, Institut Teknologi Bandung, Insinyur Edwan Kardena, PhD, to give his opening speech. Ladies and gentlemen, please welcome Insinyur Edwan Kardena, PhD.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. His Excellency yang terhormat Bapak Luhut Binsar Panjaitan, Menteri Koordinator Bidang Maritim dan Investasi. Yang terhormat His Excellency Bapak Dr. Insinyur Basuki Hadimulyono, Menteri Pekerjaan Umum dan Perumahan Rakyat, distinguished guest, Professor Satoshi Okabe from Hokkaido University. Nice to see you again, Professor Satoshi. Professor Louis Key, the Vice President for General Affairs, and also Professor in Civil Engineering of National Taiwan University, who is today also the keynote speech for this conference, and others professors from our partners university, distinguished guests, ladies and gentlemen. It is my great honors to welcome you all to our 4th International Conference on Sustainable Infrastructures and Built Environments. We call it SIBE 2020, which is this time in collaboration with our French University, Hokkaido University, and also National Taiwan University. The theme for this conference today is Challenges on Sustainable and Resilient Infrastructures and Built Environments. It is a very important topic, and the conference will cover all aspects of, in alphabetical order, civil, environmental, and oceans engineering practices, also research areas, covering a broad topic from disaster and resilient infrastructures, earthquake engineering, sustainable construction and project management, maritime infrastructures and coastal protection, transportation system and engineering, water resources engineering and management, clean and renewable energy, water, food, environment nexus, climate change and air pollution, and also health, safety and environments, solid waste and hazardous waste, and water and wastewater treatment process engineering. Ladies and gentlemen, distinguished guests, we are witnessing the rapid growth of world populations in the country like Indonesia, where the activity of economies still focus happens in the big cities, and also industrializations, and this force people moving to urban area, to the cities. We call it the urbanization. So I think this will create a problem, and our task how to solve this problem, like for example, providing the health infrastructures, water supplies, and also others important infrastructures. So to me, I think the fast-growing population must be followed by fast-growing or infrastructures, not only just infrastructure, but it should be green, sustainable, and also resilient. We are make a kind of development today, and we have to care our resources because we need to sustain our resources for our children. So we have to be very fast in developing all kind of infrastructure, but also we have to care of our environment. And I hope that the SIBE conference will be able to provide a platform for exchange ideas, information, and experiences among academic, researchers, consultants, engineers, manufacturers, and postgraduate scholars. And it also can be a medium for us to discuss and evaluate, and also, of course, to structures, development, pollution prevention, and eco-friendly technologies adapted to developing countries like Indonesia. Lastly, I would like to thank the sponsors who has been supporting for this conference. Of course, the organizing committee, Bu Rector, for supporting us, all students who have been working tenaciously to organize this event. And I would like to say, enjoy your time at this conference, and I hope we have wonderful discussion and potential collaboration in the future. Wassalamualaikum warahmatullahi wabarakatuh. Very good morning to all of you. Thank you.
Thank you very much, Insinyur Edwan Cardena, PhD, for the motivating opening. Next, we would like to invite her at her opening speech and to officially open the international conference. Ladies and gentlemen, please welcome Professor Reni Wirahadikusuma, PhD.
Mia. Okay. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Hello everyone. Yang terhormat keynote and invited speakers, invited guests, our dean, our chairperson of this conference, my colleagues at ITB and all other universities, participants, ladies and gentlemen. So on behalf of Institut Teknologi Bandung, I welcome you to the 4th Sustainable Infrastructure and Built Environment, or as we call it, SIBE. It is an international conference organized by the Faculty of Civil and Environmental Engineering of ITB, in collaboration with Hokkaido University in Japan and National Taiwan University in Taiwan. So thank you both our partners, and especially thank you the dean, my friend, my colleague, Dr. Edwan Cardena and Ibu Indah Rahmatia for inviting me to open this wonderful event. Especially this morning, I, representing Institut Teknologi Bandung, would like to express our gratitude. We feel very honored to have all the keynote and invited speakers today. Yang terhormat Bapak Luhut Binsar Panjaitan, Bapak Menteri, the Coordinating Minister for Maritime Affairs and Investment. Yang terhormat Bapak Dr. Basuki Hadi Mulyono, beliau adalah the Minister of Public Works and Housing of Republic of Indonesia, and then our invited speakers and our longtime colleague, Professor Satoshi Okabe from Hokkaido University, Dr. Fuad Bendi Maerad, the Executive Director of Earthquake Megacity Initiative, or EMI, Professor Luis G, or probably Luis G, yeah. Apologize if I pronounce your last name inaccurately. Professor G is the Vice President for General Affairs, Professor of Civil Engineering. Oh, so you are my colleague. I'm also from Civil Engineering from the National Taiwan University. And then next, Professor Michael Templeton, the Professor of Public Health Engineering, Imperial College of London. Dan juga yang terhormat Bapak Abdul Malik Sadat Idris, ya, Director of Water and Irrigation from the Ministry of National Development Planning of Republik Indonesia, Bappenas. Ini rekan kami sesama alumni sipil, juga beliau adalah Ketua ALSI ITB, ya, ITB, alumni Teknik Sipil ITB. Profesor Tadashi Yamada, the Graduate School of Engineering from Kyoto University, Japan. And last but not least, our representative from the International Water Association organization. So we thank you very much for making your time, very valuable time and knowledge and experience to share with all of us. And also, we would like to extend our appreciation to the institutions that have supported this activity, including our sponsors. I would like to tell a little bit about this SIBE conference. It has a long history within the Faculty of Civil and Environmental Engineering, in which I'm one of the member of this faculty. So the first conference was held in 2009. So, and it has been held every 4 years. Now it's the fourth. Today, we would like to focus on the theme on challenges on sustainable and resilient infrastructure and built environment. So it is indeed so many challenges in our topic today. So the current and complex environmental and infrastructure challenges due to urbanization, industrialization, and climate change have become threats to human life, to all of us. So these problems are exacerbated by, of course, the pandemic. It has been 2 years now. So we all are in the middle of the crisis like we have never experienced before. Especially us in Indonesia, we are one of a developing country. We lack the infrastructure. We have so many development, but there are still some improvements that we have to solve to support economic development of Indonesia. And we understand infrastructure is a basic human need, and a sustainable and resilient infrastructure system is very, very essential for the survival, the health, and the well-being of all of us. We, the engineers, from with our background in civil, environmental, and ocean engineering, we understand our role, our strategic role to tackle these complex problems, but we have to collaborate. And then the way to solve our problem is with a holistic approach. Frontier research into effective infrastructure design, as well as a clear regulatory and policy development framework, are necessary for a sustainable and resilient built environment. So indeed, challenges or problems in infrastructure, especially public infrastructure, are mostly non-technical or non-engineering. So we have to deal with mostly in financing, social, political. So we engineers have to understand all those non-technical or non-engineering problems. And we have the responsibility to make the best technological decision, but not just technology, but we have to also consider financial, social, political, and environmental issues in order to improve or double our impacts, in our result, in our problem solving. And we have to improve in engaging experiences, and we have to understand the disruptions toward a sustainable and resilient future. So therefore, this conference is the right place. This is a dissemination platform. So thank you, Faculty of Civil and Environmental Engineering, for executing this very important event, because this event will encourage discussion, nurture our ability to, this is very important, multidisciplinary thinking. So multidisciplinary thinking, we still have a lot of work to master this multidisciplinary thinking. So we are holding this international conference with the hope of researchers, academics, engineers, industry partner, government agencies will be able to work collaboratively using both our cutting edge insights about the challenges we are facing together. So finally, to wrap up, we are very optimistic. We can solve and we can achieve a sustainable, resilient future, especially in Indonesia. However, of course, we truly understand that we will need to collaborate and innovate. And we will need to foster interdisciplinary thinking in the development of infrastructure and the built environment. But again, I am confident, ITB is confident, optimistic that the next few days in the future will be, and the future ahead will be successful and fruitful for all of us. So I wish you best of luck with this conference. Please stay happy, healthy, networking, making good friends. So with this, I declare that the 4th International Conference of SIBE 2022 is officially open. Thank you for your kind attention and support. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Professor Reni Wirahadikusuma, PhD, for the encouragement and appreciation. Ladies and gentlemen, we will now continue with our next agenda, which is the photo session. Please kindly, professors, kindly go to the podium. Yeah, thank you. And take your positions. Also, ladies and gentlemen who are online via Zoom, please open your cameras. Okay, yeah, everyone, please open your cameras. And then we will start on the count of 3. We will take your photos. 1, 2, 3. Okay, hang on, yeah. Hang on a second. For ladies and gentlemen who have not opened their camera, please do so that we have a very good memory, a wonderful memory to start the event, right? All right, on the count of 3. 1, 2, 3. Yeah, and on the next page. Yeah. 1, 2, 3. The next page. 1, 2, 3. The next page. 1, 2, 3. The next page. 1, 2, 3. Okay, thank you very much, ladies and gentlemen. have nearly come to the end of our opening ceremony for the 4th International Conference on Sustainable Infrastructure and Built Environment 2022. However, before we move on to the next agenda, which is the plenary session, we would like you to welcome with a traditional song performance titled Sik Sik Batu Manikam and Manuk Dadali by Institut Teknologi Bandung Choir. Please enjoy the performance.
Bong 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 bong
Sik batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula jula. Sik batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula jula. Habang birik birik sa tabi loloanon di patilik-tilik, oh hinamura ponon. Sik si batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula jula. Sik si batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula jula. Daun tutu si hupi yang boso masuga-suga. Daun tutu na uli yang boso dengan maroha. Dadadadadam, 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 dadadadadam. Sik si batu manikam, dadadadadam, dadadadadam. Sik si batu manikam, dadadadadam. Sik si batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula jula. Sik si batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula jula. Sik si batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula. Sik si batu manikam ni parjoget sarmani gotam dina mangingani si bambang kara jula jula si bambang kara jula jula. Horas! Masat ngapuluhur jauh di awang-awang, beber kencanjang na bangun taya karirang, kuku narangga sejempa matuk nageluk, kapak mega bari bernatari dulu. Saha anu bisa nyusul kana tandangna, kandang jempak tentang kaya bandinganana, tipika gibir tipika serap kusa sama, kaya karangkan kasihan leber wawanena. Manuk dadali manuk panggagahna, parlambang salam sakti Indonesia Jaya. Manuk dadali pangka koncarana, resep ngahiji pusaka benah hirup sauyuna harapan iri-iri, silipikanya ataingkis bela pati. Manuk dadali ngandung silokasi natria, kesagumna bangsa di negara Indonesia. Manuk dadali manuk panggagahna, parlambang salam sakti Indonesia Jaya. Manuk dadali pangka koncarana, resep hijau sakabena hirup sauyuna tarapa diri silih pikanya ataing iskelapati manuk dadali ngadu silokasi natrian kasakuna bangsa di negara Indonesia. Manuk dadali manuk panggagahna parambang sakti Indonesia Jaya. Manuk dadali pangka koncarana resep ngahiji sakabena.
Distinguished ladies and gentlemen, please allow me to inform you of the agenda today. The conference will be divided into 2 sessions. First of all, we are honored to have the opportunity to invite our 3 keynote speakers for the first plenary session, Mr. Luhut Binsar Panjaitan MPA, as the Coordinating Minister for Maritime Affairs and Investment, Professor Satoshi Okabe from Hokkaido University, and our third keynote speaker, Professor Louis Ke from the National Taiwan University. The 3 honorable keynote speakers will be attended by moderators from academic staff of Faculty of Civil and Environmental Engineering Institute Teknologi Bandung. After the coffee break, we will have the first parallel paper presentation session. And after the lunch break, we will have the second parallel paper presentation session. And shortly after another coffee break, we will have our third parallel paper presentation session. Ladies and gentlemen, I am sure that all speakers, presenters, and participants here are all excited to start the plenary session and to discuss together. So without further ado, let's start our main agenda. The first plenary session with our first keynote speaker, Professor Satoshi Okabe from Hokkaido University. Ladies and gentlemen, I would now like to invite you all to listen to the first keynote speaker, Professor Satoshi Okabe from Hokkaido University, who will talk about technological innovations of human-destroyed nitrogen biogeochemical cycles. This session will be moderated by Dr. Herto Dwi Arishadi, ST.MT. First of all, I would like to share a brief introduction of our moderator. Dr. Herto Dwi Arishadi, ST.MT, is an associate professor at the Faculty of Civil and Environmental Engineering, Institut Teknologi Bandung. He obtained his bachelor's and master's degree from Institut Teknologi Bandung and obtained his doctoral degree from Hokkaido University, Sapporo, Japan. He is now also actively involved in the Environmental Management Technology Research Group of Institut Teknologi Bandung. We will join Dr. Herto Dwi Arishadi, ST.MT, and Professor Satoshi Okabe now. So please, I invite Dr. Herto Dwi Arishadi, ST.MT, to moderate the first plenary session. Ladies and gentlemen, please welcome Dr. Herto Dwi Arishadi, ST.MT.
Thank you. The opportunity from the Master of Ceremony. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests, ladies and gentlemen, welcome to the plenary session of our 4th International Conference of Sustainable Infrastructure and Built Environment 2022. As the Master of Ceremony has introduced me previously, my name is Herto Dwi Aryasiadi, and I am the faculty member of Faculty of Civil and Environmental Engineering ITB. From now on, I will be serving as the moderator of these sessions. In this first opportunity, we will be hearing a presentation from Professor Satoshi Okabe of Hokkaido University, Japan. We are really grateful and honored to have him for becoming one of the keynote speakers of SIBE 2022. Professor Satoshi Okabe obtained his PhD from Environmental Engineering Center for Biofilm Engineering, Montana State University, US. He became a professor in Division of Environmental Engineering, Faculty of Engineering, Hokkaido University since 2008. He is globally respected expert and actively involved in numerous academic societies, such as the board member of International Society for Microbial Ecology, International Water Association, and also Japan Society on Water Environment. Currently, he is the president of Japan Society of Microbial Ecology. He is also the editor for certain highly reputable journals, for instance, the ISME journal, and also Water Science and Technology, Biodegradation, Environmental Technology, and also water research. His expertise is mainly on biological wastewater treatment system development, and he published a lot of scientific papers in various peer-reviewed international journals in the field. Based on those respected achievements, of course, me myself, as one of his former students, I'm very proud to have him to be my sensei. Today, Professor Satoshi Okabe will deliver us a keynote presentation entitled Technological Innovation of Human Destroyed Nitrogen Biogeochemical Cycles. I think this is a very important topic, as we know that the conversion of nitrogen can be carried out through both biological and also physical processes. The majority of Earth's atmosphere is atmospheric nitrogen, but however, atmospheric nitrogen has limited availability for biological use, leading to a scarcity of usable nitrogen in many types of ecosystem. Sensei, you will have total 30 minutes for your presentation, and there will be no question and answer session after your presentation. To Professor Satoshi Okabe, now the time is yours. Thank you.
Thank you. Can you hear me also that the screen is okay?
Yeah, Sensei is fine, Sensei, please.
Okay. Thank you very much for a very kind introduction, and I'm very much happy about this invitations for fourth International Conference on the Sustainable Infrastructures and the Built Environment 2022. I wish I could meet you in Indonesia, but this COVID-19 situation is still not good in Japan also, as well as in Indonesia. So I want to talk about today nitrogen cycle, but this nitrogen cycle is totally destroyed by human activity. So my presentations, I would like to introduce some technological innovations for mitigation of this human destroyed nitrogen cycles. So this morning, I looked at the website to find out the world populations this morning. It said that about 7.9 billion people living on this earth, increasing with a rate of 137 persons per minute and 200,000 persons per day, and 70 million persons per year, increasing. So that's, we have pretty much number is increasing right now. So I think energy and water, food sustainabilities are, of course, very important issues to solve. So this is probably main topic for this conference. So today I'm going to talk about this water sustainability mainly, okay, water sustainability. So as Professor Edwan, he mentioned in his opening ceremony speech, we are facing very serious global issues, such as the global warming and climate changes and food shortage. Those issues must be solved. We are happy to collaborate with all of you to solve these problems, urgent issues. So if you look at this plenary boundaries, this is very familiar now. So plenary boundaries concept presents a set of 9 planetary boundaries within which humanity can continue to develop and thrive for generation to come. So if you look at this red color indicates that this is already we are facing to a very serious high risks, okay, for biosphere integrity, especially genetic diversity. And if you look at the geochemical cycles, nitrogen cycle is a very serious problem, already exceed our planetary boundaries. Only 3 boundaries, we are facing very serious problems. So, because human has converted inert soil and atmospheric nutrients such as nitrogen gas into reactive fertilizers flows that endangers water qualities and biodiversities and climate changes. So if you also look at this global nitrogen cycles, human-driven nitrogen input, such as agriculture input, also industrial input to the environment, increased significantly in the last centuries, now exceed natural and nitrogen input. Okay, this is nitrogen. If you look at the industrial fixation amount is 120 times 10 to 6 tons per year, which is more like comparable with the biological fixations. As a consequence, the global nitrogen cycle has been significantly altered over the past centuries. Human-driven nitrogen input has doubled the natural nitrogen cycle rate on this land. Okay, so as you can see here, this is a mass balance for nitrogens in ocean. If you look at ocean, it is okay because the nitrogen balance is about balanced. However, land net balance is completely destroyed by industrial fixations. Okay, as you can see here, about 100 times 10 tons per year are of nitrogen, excess reactive nitrogens are accumulating in this land. And then some of them are actually discharged into the aquatic environment, which cause, of course, serious environmental problems. So this is one of the main results of the excess nitrogen usage, eutrophications. Okay, eutrophications causes the safety of the drinking water problems. Okay, we cannot actually use this water for drinking purpose. So another issues of the nitrogen excess nitrogen usage is that the groundwater contaminations. As you see here, you fertilize the ground to grow these vegetables. We are actually contaminating the groundwater with nitrite and nitrate significantly nowadays, and also pathogenic bacteria and the viruses are contaminated in the groundwater, which cause human health risks. So as you can see that the groundwater cannot be no longer used as the drinking water source. Oh, sorry. So if you look back to the human-driven nitrogen input, okay, industrial nitrogen fixation is produced, processed by this Haber-Bosch process. as I indicated like this, nitrogen gas was combined with the hydrogen at very high temperature and high pressure with help of this catalysis, okay, ion-based catalysis. But this, the Haber-Bosch process is a very energy demanding process. About 1%, 1 to 2% of world total energy supply was consumed for this Haber-Bosch process. And also this process emit about 1.5 to 1.6 tons CO2 equivalent per 1 tons of ammonia produced, which account for about 1.2% of the atmospheric anthropogenic CO2 emissions nowadays. And moreover, we are not using this fixed nitrogens very efficiently. If you look at this, so this is an N fertilizer, so produced by this Haber-Bosch method, defined as a 100%. So we put this fertilizer into the ground to grow their vegetables. So many processes, fertilizer applied and the crops, the uptake by the crops and harvested by human being, and then we cook and we finally eat. But as you can see here, only 14% of the nitrogen produced by very energy demanding Haber-Bosch process enters our human mouth. Okay, so only 14%. The rest of the 86% accumulating in the ground. Okay, so that heavy use of industrial nitrogen fixation is severely disruptive to our global nitrogen habits cycles. You should remember this. And also, this is a kind of the very simplified the biological nitrogen cycle. So that we, as I mentioned, that we fix the N2 gas by Haber-Bosch method, about 120 times 10 to 6 tons per year, with huge amount of the energy, about 1% of the total energy in productions, and we emitted that 1.2% of the carbon dioxide into the atmosphere. Then the excess amount of the nitrogen was actually treated by domestic wastewater or industrial wastewater treatment with a lot of energy consumptions. As I indicated here, that the two fixed nitrogen gas, we need this much energy, 10 kilowatt hour per kilogram ammonia nitrogens. Remember this, 10 kilowatt hour per kilogram nitrogen, ammonium nitrogens. And to treat our wastewater, we spend 3.5 kilowatt hour per kilogram ammonia nitrogen removal. Okay, so we fix nitrogen with a lot of energy consumptions. Then also we treat nitrogens with a lot of energy, but we cannot remove all of them, so that the remaining nitrogens goes to this aquatic environment, and which causes, of course, severe eutrophication problems, water pollution problems, and groundwater contaminations. So it is not sustainable anymore in terms of this biological nitrogen cycles. This is totally destroyed by the human activity. So we have to mitigate this human destroyed global nitrogen cycles with less energy input. So today, I want to introduce for you two main nitrogen removal and recovery processes. One is the ANAMOX. This is a biological, the nitrogen removal process, and also bioelectrochemical processes. These are the main, very promising nitrogen removal and nitrogen recovery processes in coming centuries. So this is just for comparison. That now we are using this is conventional nitrification and the denitrification process, as you know very well. First, ammonium nitrogen was oxidized to nitrite and nitrate with aerations, oxygen. Then this nitrate was actually reduced back to atmospheric nitrogen gas. So you need this two-step nitrification, denitrification process. This process consumes 3.5 kilowatt-hour per kilogram nitrogen removed. Okay, and also this the denitrification process, we need external carbon source additions, about 3 kilogram methanol per kilogram of nitrogen removed. Okay, so this is not sustainable anymore because it's too much energy consumptions and too much cost for this external carbon source. Mainly, this energy consumption is due to the aerations to supply air, okay, for these nitrifications. About 55% of the energy consumption is due to aerations. So here comes out the new microbiology, microorganisms we called Anammox bacteria. This is an anaerobic ammonium oxidizing bacteria. This bacteria does not need oxygen as an electron acceptor. Instead, they can use nitrite NO2 as an electron acceptor. So we don't need to aerate this process bacteria. So the ammonia and nitrite directly combine to dinitrogen gas without oxygen, okay? Without oxygen. So as you can see that implementation of this Anammox bacteria in a nitrogen removal process is following like this. The first, ammonium must be partly oxidized to nitrite NO2 because Anammox bacteria, they need nitrite as an electron acceptor. So partially we oxidize to nitrite. Then second step, this ammonia and nitrite react with Anammox bacteria, they uptake ammonia and nitrite, then convert it to the dinitrogen gas without any oxygen. So you can actually get this two-stage nitrifications, partial nitrification and Anammox process, or you can just make a single reactor in which both partial nitrification and Anammox took place in this single step. Okay. So if you compare the conventional process and this partial nitrification Anammox process, as you can see here, you can reduce a lot of energy and methanol for denitrifications, okay? Because you don't need to aerate so much because you don't need this nitrite oxidation to nitrate. So you don't need this aerations. So you need only 0.75 oxygen, moles of oxygen. So you can actually reduce the aerations by 65%. And also methanol addition was reduced by 100%. As a result, if you look at the energy consumptions, right, conventional treatment, up to 3.5 kilowatt-hour per kilogram nitrogen, whereas partial nitrification and Anammox processes only requires 1.0 kilowatt-hour per kilogram nitrogens. Methanol, we don't need for Anammox process, and CO2 emissions, yes, we can reduce significantly down to 0.7 kilogram CO2 equivalent per kilogram nitrogen removed. And the total cost, of course, we can reduce half by half, right? So this nitrogen, the partial nitrification and the Anammox process is very cost effective and energy-saving nitrogen removal process. So therefore, full-scale ANMOX plants were actually already constructed mainly in Europe and also in China. More than 120 full-scale plants are right now in operations. So if you also look at the CO2 emissions, I think we can reduce significantly CO2 emissions. Okay. So now mainly this ANMOX process is applied for mainstream wastewater treatment. Mainstream is it's here, right? So the aerations, this ANMOX process is mainly applied for side stream applications. Side stream application is that the treatment of the sludge produced in this mainstream, so that anaerobic digestions. After that, we have a very high, rich reject water. Okay, so the treatment of the reject water, we use this partial nitrification and ANMOX process. So mainly, ANMOX process was applied for side stream applications. So challenges is to apply the ANMOX process to mainstream applications. Okay, so mainstream means that replace with this activated sludge process with ANMOX process, or maybe including ANMOX process in conventional activated sludge systems, which has not been done yet, because this is kind of the obstacles of these challenges, because it's difficult to control the partial nitrification in the very weak, low nitrogen containing domestic wastewater, and poor effluent water quality, and low temperature mainly. Okay, those are the things we have to solve in order to apply ANMOX process to mainstream applications. So we are actually working on the scale-up ANMOX process with the help of the Korean companies. So we actually developed that full-scale plants like this. Capacity is about 220 cubic meters per day, and also another one is 70 cubic meters per day for treatment of rejected water from the anaerobic digestions. It took about 3 years to scale up from the laboratory scale reactor up to full-scale plant. So we are actually now expecting to construct this full-scale plant in Busan, and also the Busan and the Daejeons, okay, for treatment of the reject water and livestock food waste digester and the landfill leachate, and also the mainstream applications is also planning in the USA, and the reject water treatment and the livestock wastewater. So it's a very promising. So next technology.
Dia memang ada acaranya jam 9.30 nggak bisa diundur. Sorry, I think there's some little noise here. So please unmute. Please mute the speaker.
Yeah, well, thank you.
Okay, thank you. I think you can continue your presentation.
Okay, thank you very much.
Yeah.
Well, the next technology I would like to introduce to you is that electrochemical systems. Okay, this is kind of new, but it's very promising. Okay, I can show you later our results, but first I would like to start with this concept. Okay, this is a kind of microbial fuel cell, and the anode compartment and the cathode compartment, they are separated by this cation exchange membranes. Okay, so that this ammonium NH4+ can move from this anode to cathode, because we apply the wastewater to this anode compartment, so the ammonia-rich water in this anode compartment. So that's ammonium ion goes to cathode, okay, because of the concentration gradient. Then this ammonia is oxidized to nitrate. Then this nitrate is denitrified with the electrons coming from this anode compartment via this external electrical circuit to cathode. Okay, so this is a cathode denitrifications. We don't need to add any extra external carbon source, but just to use these electrons to reduce this nitrate to dinitrogen gas. Okay, so this is the ammonia removal by MFCs, microbial fuel cell. Same times, we can actually generate electricity, but this electricity is not much, but can be used in situ. Okay, so this is one of the applications. Another application is the ammonia recovery with MEC. Okay, this is the microbial electrical cell. The concept is similar, but the difference between the MEC and MFC is here. We apply the potential, we apply the voltage, okay, by using this potential start. So we actually put external energy input into this MEC so that we can control the potential of the anode and the potential of cathode in order to get these reactions, oxygen, the water oxidations, and also this is the hydrogen productions in cathode. Again, we have this cation exchange membrane so that ammonium ions can transfer from anode to cathode. But here you see that alkali hydroxide ion is produced by this reaction so that the pH goes up, then ammonia become ammonia like this. Then at high pH, well, ammonia is stripped, okay, goes to the gas phase. So in order to collect this ammonia with this stripping devices and also absorption devices connected with this MEC reactors, so we can actually recover the ammonia instead of we are removing ammonia. Okay, so we can use recovered ammonia as a fertilizer. Okay, so here is a stripping devices and also the absorption column associated with this MEC. So the advantage of using this MEC is to produce hydrogen gas, and also we can actually get the good nitrogen, ammonium nitrogen recovery. So just I want to show you that our experimental results. So we constructed this MEC type reactor for ammonium nitrogen removal. So I cannot actually talk about the details in this the reactor, but we constructed this the reactor. Then we applied the potential plus 0.7 volt at air cathode. Okay. So as a result here, this is ammonia concentration, influent ammonia concentration using the real domestic wastewater. So the ammonia concentration influent was about 60 milligrams per liter, and our effluent shows that's a very nice ammonia removal. So let me explain this, the condition, experimental condition is, this is a closed circuit. Okay, closed circuit, MEC was actually connected, okay, with the electrical circuit, but without applying potential. So that period, ammonia removal is okay, just okay, about like 40% of the ammonia was removed. But when we start applying voltage, 0.7 volt at cathode, immediately ammonia removal was improved like this, almost 90% of the ammonia was removed, okay? to make sure that this is the real things, so that because of this effect of the applying the voltage, so we just cut this voltage and we actually open the electrical circuit in this phase 3. As you can see here, as soon as we open this electrical circuit, nitrogen removal was deteriorated. Okay, so the ammonia concentration in effluent increased rapidly, and ammonia removal was only at 10 or 20%. Again, to make sure that this reproducibility of these reactions, high, good nitrogen removal, by applying a voltage. So we actually closed this electrical circuit, then we apply the voltage, 0.7 volt at this cathode. Okay, again, as you can see here, immediately nitrogen recovery, nitrogen removal was improved. Okay, recovered, very good nitrogen removal. And as you can see here, after about 3 months, we had the very stable nitrogen removal in MFC1. So means that we closed that this condition was actually applied for MFC1. Same times, you see, as you can see, the electricity was actually generated because of the this is a kind of MEC systems. So you can get this very high electrical current, okay, simultaneous generations. So if you look at here, you see, this is the without electrical circuit. So that means that aerobic ammonium oxidations take place here. But if you put potential 0.7%, 7 volt at the cathode, we can improve the nitrogen removal by double. Okay, then we got like a maximum nitrogen removal rate, ammonium nitrogen removal rate of 150 grams ammonium nitrogen per cubic meters per day, which is quite high nitrogen removal rate, okay, as compared with the conventional activated sludge systems. So this is probably due to the enhancement of the both respiratory pathways, which means that electrode associated anodic ammonium oxidations and aerobic ammonium oxidations. So what this means, anodic ammonium oxidation is because ammonia oxidizing bacteria, they use anode as an electron acceptor instead of using oxygen as an electron acceptor. So use this anode as an electron acceptor, they oxidize ammonia to nitrite. Okay, this is anodic ammonium oxidations. This is kind of typical conventional aerobic ammonium oxidations using oxygen as an electron acceptor. Okay, so both respiratory pathways are actually taking place in our MEC. Therefore, we got the very high ammonium nitrogen removal. Okay, so for application of this MEC technology, especially developing country like Indonesia, where I assume that there is no public sewer systems are well developed, means that there is no sewer lines or constructed yet. So maybe each houses, they have septic tank, okay, like this, okay, to treat their household wastewater. So we think that we can implement this MFC or MEC technology into this septic tank systems so that we can remove nitrogens, phosphorus, of course, COD simultaneously, and we can reduce the sludge productions, because this MFC technology can reduce the sludge significantly. So this is probably one of the very important application of this MFC or MEC technology in septic tank systems. So because here, you see energy requirements for this microbial electrolysis system is very, very low. Yeah, as you can see here, volumetric nitrogen COD loading rate is maybe equivalent as this anaerobic digestion, but sludge production is low and nutrient recovery, we can expect it. And also energy consumption is, as you can see here, is low, relatively speaking. Also that we can get very variable hydrogen productions, simultaneous hydrogen production can be expected. So maybe we can use these hydrogens as an energy source, okay? So I think this, the MFC or MEC technologies implemented in the septic tank system is very good opportunity for Indonesian countries for wastewater treatment to prevent the water environment in the future. So with that, I think I would like to finish my talk with this the pictures. This year in Sapporo, we had the record-breaking snow, deep snow, which is, I think that this is the climate change already happened in Sapporo, okay? Because we had almost like a 4-5 meter snow accumulation so far. So this is one of the picture I took. This is our Faculty of Engineering backside, but we cannot see because of the lot of snow accumulated on these trees. So with that, thank you very much for your kind attentions.
Okay, thank you very much, Professor Satoshi Okabe, for addressing this very interesting topic. And then I pointed out some important message here that the nitrogen cycle is of particular interest because nitrogen availability can affect the rate of key ecosystem processes, including primary production and also the decomposition process, and also the human activities such as fossil fuel combustion and use of artificial nitrogen fertilizers, and also release of nitrogen in wastewater have dramatically altered the global nitrogen cycle. And finally, this human modification of the global nitrogen cycle can negatively affect the natural environment system and also for the human health. That therefore we need to manage this human destroy nitrogen biogeochemical cycle by implementing technological innovation such as anamox and also microbial fuel cell technology in a sustainable way. This is the end of our conversation. On behalf of SIBE 2022 committee, I would like to present a high gratitude to Professor Satoshi Okabe for being with us today in this conference. Wish to see you again in the next event. We would like also to thank all of the attendants for your very kind attention. And I return the event room to Mrs. Smita as the Master of Ceremony. Thank you very much. Good morning.
Thank you very much.
Thank you.
Thank you very much, Professor Satoshi Okabe and Dr. Herto Dwi Arishadi STMT for the comprehensive explanation. Distinguished ladies and gentlemen, we would like to inform you that Mr. Luhut Binsar Panjaitan MPA will be joining us today at 10 a.m. Western Indonesian time. We ask for your understanding, so thank you. Distinguished ladies and gentlemen, let us proceed with our next agenda. I would like to invite you to the second part of our plenary session with our second keynote speaker for today, Professor Louis Ge from the National Taiwan University, who will share with us his insights on the development of calcite precipitation techniques to ground improvement on liquefiable soil. This plenary session will be moderated by Insinyur Rildova MT PhD. Ladies and gentlemen, let me give you a brief introduction of our moderator, Insinyur Rildova MT PhD. He is an associate lecturer at the Faculty of Civil and Environmental Engineering, Institut Teknologi Bandung. He obtained his bachelor's and master's degree from Institut Teknologi Bandung and obtained his PhD from Virginia Polytechnic Institute and State University, Virginia, United States of America. He is now actively involved in the Offshore Engineering Research Group, Institut Teknologi Bandung. Without further ado, I now invite Insinyur Rildova, MT PhD, to moderate the plenary session. Ladies and gentlemen, please welcome Insinyur Rildova, MT PhD.
Thank you, Ms. MC. Good morning, ladies and gentlemen. It's a pleasure for me to introduce to you our next keynote speaker, Professor Louis Ge from the National Taiwan University. Professor Ge is a professor of civil engineering and also vice president for general affairs at the National Taiwan University. He also serves as executive secretary for the program office on innovative technology for disaster reduction in the Ministry of Science and Technology of Taiwan. His current research works includes soil liquefaction, which he will talk about this morning, which includes investigation, evaluation, simulation, and mitigation of soil liquefaction. More of his CV is shown on the screen. You can see quite a long professional experience. And without further ado, I will give the screen for Professor Ge to present his works on the development of calcite precipitation technique on ground improvement on liquefiable soil. Please, Professor Ge.
Thank you for your kind introduction. So let me share my screen. So this is my pleasure and honor to share with you the current progress of research on this MICP technique. I'm sure this is going to be kind of helpful in terms of liquefaction mitigation. As the research is going on, I don't have much on the liquefaction part of it, but we have spent some time on looking into the using the technology in how we do in the laboratory environment. So there are several bio-cementation process in a geological environment. We are utilizing what we call the mineralization in organic process. This microbiological precipitation. The example of that mineralization is producing calcite. So there are also a organic way of this bio-cementation process, but our focus is using this inorganic approach to in our soil improvements. So in terms of the rock formation, there are a physical, chemical, and also a microbiological process. So as you can see, there are some evidence and pictures on this process. Now, they are evidence in a geological environment that we can see these microbial activities. The figure you see in here on the right, there are some a dark black images. They are the evidence of these microbiomes. So this is a dolomite in a limestone. So in terms of this mineralization process, they are 4 types. The one that we are using is what we call the urea hydrolysis, where you can see this a chemical reaction equations on the top. We are utilizing the urea and with a proper environment by increasing the pH level so that we can release the calcite precipitation. This is a aerobic process, unlike some other approaches that they are an anaerobic process, including this sulfate reduction, iron reduction, and denatrifications. I won't talk too much about those 3 processes, as I'm not a good with a background in the chemistry and environmental engineering. But instead, we will be focusing on the urea hydrolysis. So we work closely with faculty members in our Institute of Environmental Engineering on the campus of the NTU. So if you look at this a mechanism of the urea hydrolysis, they are basically 2 types. They both of them they are producing this calcium carbonate precipitation. One is using a bioprocess we call the MICP. The other one we call this the EICP. Instead of microbiomes, we are using the enzyme to produce the calcium carbonates. So this is a process where you have a urea, and then you add up some ureas to serve as a catalyst to create environments that with a high pH level, so that you can release these calcium ions to make a calcite to precipitate. Instead, if you are using the ureas as a enzyme, they can also produce this a calcium carbonate precipitation without using a microbiomes. So they are basically a 2 type. So these microbiological processes can be found in various area and subjects. For example, the one we are focusing on the geotechnical engineering, you can use that for a ground improvement for foundation or slope stability, and also we can use that to mitigate the liquefactions. In some of the construction materials, researchers and people have been using that in a concrete strengthened, and also for the sludge consolidation. Now, if you look into the MICP technique, there are several mechanisms of it. But the urea hydrolysis is the most common one that used in the literature in the research. This precipitation takes place rather quickly, and it is a more like a long-term methods for liquefaction mitigation, as we can always add on some of the nutrition solutions to have a long-term behavior of this process. And if you look at the MIDP, this is another way of a calcite precipitation, but it is involved with a desaturation, where we call this a denatrification. And also another part of that for the precipitation, the amount of the process is much slower than the MICP process. So this is more like a short-term mitigation methods for the liquefaction. Now, people have been studying the effects and also some factors that influence the MICP process. As you can see, they are depending upon the bacterial type, and including the concentration or the size or shape of bacteria, and then depends upon your soil particle size, void space. If you have a very large void, you will be not that effective. If you have a smaller void size, and also the environment for the chemical solution, the pH level, and then the temperature will also have impacts on the performance of this MICP process. And also, if you look at in the laboratory environment, the injection of the this MICP fluids solutions to specimen is very challenging. We are dealing with a lot of the difficulties that happening in the lab to make a uniform specimens so that we can evaluate the performance adequately. Now, we know this process that can be with this MICP taking place in soil. It can reduce the permeability of the soil. It can increase the stiffness and also decrease the compressibility and increase the shear strength of the soil. And also the volumetric response is up and down, depends upon the soil type. If you are looking at a large scale, in the field scale, and how we can apply this a technique that requires some geotechnology. Basically, we are using the grouting to inject the MICP solutions to the ground, so that the cost in the construction convenience are also an important factor to consider. Now, this might draw your attention that when you look at this calcite or calcium carbonate precipitation, we look into there because we want to have a cost-effective ingredients. So we look into a different source of calcium, so that the performance of this MICP they are different. Eventually, we look into the crystal type of this bonding between the particles in the soil voids. In terms of this calcium carbonate, it may have a crystal type in terms of calcite or the aragonite or the laterite. So this may have some effects on the mechanical behaviors in terms of the strength or compressibility of the soil after the treatment. So we shop around the market and then look into the type of calcium which are available in the market. And at the same time, we also looking for the candidates that are soluble in water, because we have to mix up with other ingredients to inject to the soil. And so that the solubility is an important issue. A second issue we're looking at if that is eco-friendly. For example, the calcium chloride has been frequently used in the MICT technique, but this is more appropriate for RC infrastructure type to avoid the corrosion of the steel. So this is but it's not that eco-friendly in this case. And lastly, we are also looking into the price. The unit price we listed here, although they show in these New Taiwan dollars, but they are roughly in the range of $5 US per 500 grams. So they are not that expensive, but this is only for the technical grades. If you are buying a guaranteed reagent, that basically 10 times more expensive. You can put it this way: for the technical grades, is more like a factory grade. The guaranteed reagents more like in a laboratory environment, more finer in terms of the quality of the calcium. So after we sharp those a possible source of calciums, we identify there are 4 of them. They are can be used in our study. So we'll look at into the calcium chloride, the calcium acetate, and then the calcium nitrate, and also the calcium lactate. And as the calcium chlorides, they are not that eco-friendly in this case. We are also only using these 3 other calcium type. So in terms of for the cost-effective consideration, so we compare these technical grades and also the guarantee reagents using the AICP, because that give you a more a quicker precipitation of calcium carbonates. So basically, the results shows in here. We are using the tube test. So basically, we mix the solution together to produce the these calcium carbonates, and then we try to measure the amount of the precipitation to look at. So that's you see the figure on the right. So the result basically shows that there's no significant difference between these 2 types. So because of these findings, our research using the technical grades for the sake of future larger, greater deployments in the field. So we move into the mixing for the ground improvement applications. So our the soil we are using basically sand. So this is the a particle size distribution. This is the ASP poorly graded sand, fine sand in this case. We try to establish several techniques to prepare a uniform specimens. They are basically a 2-phase injection or 1-phase injection, and also we can consider if we allow the drainage at the bottom of the specimen. So we have a drained or undrained specimen preparation methods. For the 2-phase injection, we pour our bacterial solution and wait for 24 hours. And then you add up to the urea and the calcium solution to it, and you allow it drain naturally. If you are looking at this 1-phase injection, we put this bacterial solution and the urea and calcium solution all together in 1 phase. And then we can depend upon they are drained or undrained. If it is undrained, the specimen will be soaked in the solution. Now, speaking of these bacterial solutions, we can add or without adding urea. The purpose of adding urea is to increase the pH level so that the process can speed up a little bit. But we found out that if you had a bacterial solution without adding a urea, you slow down this process a little bit later, so that you can have a more uniform specimen, as you will see later on shortly in the results. So there are three scenarios that we are looking at this specimen preparation techniques. One, we call this a two-phase condition A, and then also the one-phase condition B with drained, and also the one-phase without drained, undrained for the condition C. So these are the three type of a specimen preparation methods that we use in this study. We carry out the following three tests, a series of 4-cone tests. This is the 4-cone apparatus that you see on the upper right slides. This is a 4-cone that you allow to penetrate the specimen that we prepared. So the less penetration we have, the stronger the treated specimen will be. So basically, this is a more indirect measurement of strength. This will give you a quick evaluation of the MICP treated specimen. So after that, we do this acid digestion to determine and evaluate how uniform the treated specimen will be. So we're taking some part of the crumbs of the specimens and using this hydrochloride solution for this acid digestion. And lastly, we do some triaxial testing to look at the strength and volume change of these treated specimens. So this is still ongoing process for the huge amount of triaxial tests. So quickly look at the results. This is for the condition A, two-phase and drain 4-cone test. So you will see that the solution without the urea actually perform better than the adding with the urea. So continue for this condition A, 4-cone tests. So you can see this is all the acid digestion results. So basically, I don't go through the detail of this all the bars with the numbers, but if you look at the highlighted a summary in the lower left, this calcium nitrate shows highest forms calcite contents, but the penetration is similar to others. So condition A without adding urea makes the 4-cone specimen more uniformly. So if you look at a condition A, which is a two-phase and drain, if you look at 7 and 14 days curing time with the triaxial specimen, the total specimen, 7.2 centimeter in diameter and 14 centimeter in height. So the one cycle treatment shows a similar calcite precipitations for 7 days or 14 days. So if you look at a condition B, this is a one-phase drain. Without the urea, will obtain a harder specimen, but it's not uneven for a triaxial specimens. If you under this treatment, you can even with a hand you can punch the specimen and it got dented. But if you put it on oven dry, you will see the specimen become very hard, as you can see here in the picture. The show the video clips in here. So it's a very dry. But if that is in wet conditions, it is a soft. But you can see the cementation, the bonding from this calcite precipitation. So the condition C, the scenario C, is a one phase, and we allow this for undrained the type. So you will see this doesn't matter for the 4-cone or triaxial specimens. This is a more uniform specimen for the condition C. So later on, we are using this a method condition C for one phase undrained methods for our specimen preparation methods. So lastly, we carry out several CD tests, consolidated drain tests. As you can see, for the pure on the left one, the pure sands, it's the peak deviator stress around 318 kPa. The corresponding actual strain is taking place around 5.1%. But after you have this MICP precipitation, you can see the increase of the peak strength, and also it took place in a later strain level, so it becomes slightly more ductile than the pure sands. So this is the very preliminary results. It's very rare to see in the literature reporting a triaxial test, as they are very difficult to make a uniform specimens in the MICP environments. Likewise, if you see the figure on the right, it shows the volumetric change. You can see this a contraction and dilation behavior. Surprisingly, after the treatment, it dilates more than the pure sands. Okay, so here's my conclusion. We examining the MICP microbiological induced calcite precipitation. It would be a good method and approach for a sustainable infrastructure and the built environment. Through this presentation, we look into the calcium source, and then that is related to its crystal type. That has an impact on the strength and also the mechanical behavior of the treated soil. And we spend a lot of time looking into the specimen preparation techniques. And we selected for the condition C, scenario C, with a single phase undrained method for the specimen preparation. And then you can see this biosedimentation through the CD test I showed earlier, with some strength increase and slightly ductile and also more dilative behavior. So with that, I will finish my presentation, and thanks for your attention.
Thank you, Professor Ge, for the very interesting and timely presentation on this application of microbiological induced calcium carbonate precipitation to improve the liquefiable soil. On behalf of the organizing committee, I would like to convey our appreciation for your contribution to our conference. Thank you very much, Professor Ge. And I will return the screen to the MC.
Saya tidak dengar suaranya.
Thank you very much, Pak, for informing us about the mic issue. Okay, thank you very much to Professor Luis Ke and Engineer Rildova MT PhD for the comprehensive explanation. Now, ladies and gentlemen, I would like to invite you to the third part of our plenary session with our third keynote speaker, Mr. Luhut Binsar Panjaitan, MPA, Coordinating Minister of Maritime Affairs and Investment. This session will be moderated by Professor Insinyur Indrajati, MSc, PhD. Before we begin, let me give you a brief introduction of our moderator. Professor Insinyur Indrajati MSc PhD is a lecturer at the Faculty of Civil and Environmental Engineering, Institut Teknologi Bandung. He graduated from Institut Teknologi Bandung and obtained his master's degree and PhD degree at the University of Illinois, United States of America. Other than being a lecturer at the faculty, he is also actively involved in the Structural Engineering Research Group, Institut Teknologi Bandung. Without further ado, I now invite Professor Insinyur Indrajati MSc PhD to moderate the first plenary session. Ladies and gentlemen, please welcome Professor Insinyur Indrajati MSc PhD.
Thank you, Mita, for the nice introduction. It is my great honor to introduce the retired General Luhut Binsar Panjaitan, MPA, to the audience of the 4th International Conference on Sustainable Infrastructure and Built Environment 2022. I know Pak Luhut since 1996, when he was in charge as Chief of the Infantry Armament of the Army in Bandung. And since then, I follow a remarkable achievement, advancements, and contribution of Pak Luhut to the development of this country as Ambassador, Minister, President, Chief of Staff, Coordinating Minister of Maritimes and Investment, and also CEO. I think he is all around achiever, leaders, problem solvers, and entrepreneur as well, as marked by the many awards that he got from many associations and institutions as best ministers, earners as young entrepreneur, public leader, and so forth, and also sports. So today, we are very fortunate to him to deliver his speech in the area of the sustainable infrastructures and built environment, especially the challenge of resilience and sustainability. I think Pa Luhut will come in the next few minutes and be with for a while. And then after that, he can directly deliver his speech. Thank you. Yeah, we could understand his very tight schedule and very busy with all the activity in the cabinet. And I know that at around 10:30, he will have a meeting, the Minister of Finance. So, and then now currently he's in the middle of another programs going on. But shortly he will join us and will deliver his speech and all about related to the maritime and investment. Of course, he will talking about the infrastructure and built environment, resilience, and sustainability. His Excellency Pak Luhut Binsar Panjaitan, MPA, Coordinating Minister for Maritime Affairs and Investment. I would like to thank you for coming to this international conference. I know you're very busy and very tight schedules. I already introduced your remarkable achievement, advancements, and awards to the audience. And without further ado, I would like to invite you to deliver your speech, your opinion regarding the topics that were given to you. Thank you very much.
Thank you, Prof. Indrajati, to all of you, ladies and gentlemen. Apologize being late to deliver my remarks because I just finished with the launching of the Simbara. Simbara is the system that make it our our mineral integrated. So then we make Indonesia become more efficient in the near future. Now let me share my slide to all of you. Indonesia has a vision to become a developed country by 2045, which is, I think, I'm very confident on this, even earlier than that. I'll show you later on the data about this. And average growth 2015 to 2045, around 5.77%, which is, I believe, again, this can be higher than that because the downstream industry are already in place, and we are very rich on this area. If you look at the middle income trap, there's a 2030, but I think we can even earlier achieve this, maybe 2030. I'll show you later on about this. However, in order to achieve the vision, Indonesia needs to overcome the COVID pandemic, which is, I think, very important. The last 2 years, we are quite proud to, I'm very proud to inform you that we are able to manage this. Although we are still very cautious about this COVID, because still unknown a lot about this. Transform our economy to be less reliant on commodities, improve the efficiency of our economy through digitization, face the climate challenge by shifting toward green and sustainable economy. And over a view on the COVID-19, Indonesia has succeeded in overcoming the Delta and Omicron variant. If you look at the left slide, the yellow one is Omicron and the blue one is Delta. I think if you look at this data here, we are quite happy with these numbers. That's why I think starting yesterday, we opened Bali without quarantine. Now, high vaccination rate, more than 90%, first jab, and about 70% for the second jab. I think number of people vaccinated also, if you look at the right slide, China, India, United States, and Indonesia, and also about the vaccination doses administered, 1 million. Indonesia also rank 5. And rapid economic recovery, strong economic growth accompanied by the stable macroeconomic condition. If you look at this one, economic growth bounce back in Q4, returned to 5%. So this is, I think, the teamwork been working very hard for this, and I think this is the achievement of the government of Indonesia. We can show to the international that we are able to manage a very complex issue with a very good outcome. I think the teamwork, I think, consists of the young people of Indonesia been working together, and this is, I think, I'm proud to inform you, being the coordinator of this COVID-19 solution. If you look at this one, Indonesian export growth compared to pre-COVID is one of the highest in the world. Indonesia, China, Australia, this one, I'll show you why, because this also, last year, it was the highest ever, our export outcome. Inflation remains low and stable. As you look at now, 2.18%. Compared to other countries globally right now, like 6, 8, 9, even 10 or even double digits. So then Indonesia, I think, should proud to do this, to see this one. Rupiah remains stable despite volatility of the global market. If you look at this rupiah and the blue one, we consider it as very stable. Economic transformation, downstream industry progress, I mentioned to you earlier, this is one of the very successful so far by the government of Indonesia. We have like 7 spots like this now in eastern part of Indonesia, one in Bintan area. This is a downstream industry in the last 7 years. That I think make our economy more stable if you compare it to a decade ago. Now, if you look at also the current nickel downstream development has a focus on stainless, for a moment stainless steel, but next we move toward the battery component. If you look at this slide on the left, on the blue one on the left, this is already ongoing, this is already in production. The red one is still ongoing, still under construction. The battery, I think we're going to produce by 2024 early or maybe 23 end, and that nickel ore and MHP, the chemical component, etc., and recycle are already ongoing at the bottom. And if you look at also iron steel export to the world, last year it was, look at the 2014, only $1.1 billion, and then by 2021, it was nearly $21 billion. You can imagine during the COVID, our exports still much higher than 2020. If you see that 2020 only 11, let's say $11 billion, but 2021 it was $21 billion. Now, in improving Indonesian export and current account deficit, if you look at our export, I mentioned earlier, $232 billion export on the left side. That's, I think, the highest effort in our export in our history. And this is also 70% because of downstream industry. Of course, also with the price of CPO and the price of the coal, this also contribute to this one. But I think I would like also to share to all of you, ladies and gentlemen, not many countries like Indonesia. Our trade deficit with China, it was $20 billion before, but last year only less than $2 billion. And this year, I'm proud to tell you, ladies and gentlemen, I think we're going to be surplus because our downstream industry moving very, very well. Now, this is structural transformation through downstream industry. If you look at this one, I think the Morowali, the site of the industry, economic structure improving more complex than before. In Halmahera also as well as same. Now, this is, I think, very important to understand. Not many people yet understand in Indonesia that North Kalimantan Green Industrial Park will be the next driver for the downstream industrialization. This investment already started, groundbreaking by the president December last year, and there's construction of petrochemical is around $56 billion, and we need like 1.4 million barrel crude oil a day. I just come back from Saudi to Riyadh, and I met Crown Prince Mohammed bin Salman. That's part of my discussion. Also, the supply to this petrochemical, because this petrochemical starting production by 2024 January. This, I think, we're going to have electronic alumina, steel, and new energy battery, industrial silicon, polycrystalline silicon, and this like 70% energy by the hydropower and solar panel, and also 2.9 TCF of gas. Now, ladies and gentlemen, it will increase Indonesian export in the next 10 years. So if you look at this chart, today is 2022. So I believe this construction in the North Kalimantan, the semi-green industrial park, integrated industrial park, by 2024, our exports going to be like that. So then 2030, I'll show you later on that we're going to be much better than today. Our GDP at the time, hopefully by around $3 trillion, and I believe at the time, our income per capita can go up to $10,000. Next step, potential product development. That's, I think, you'll see this one. This is, I think, the red one is the iron and steel. That the blue one, that's our target. That I just discussed with the US and also with Abu Dhabi. They are here now, the team. They need also to invest here, as well as the Crown Prince Mohammed bin Salman. So that's, I think, very important for us. Even the Crown Prince also communicating directly with me about this issue, and he texted me yesterday also about this to see the progress. And I told him we're going to move very fast. And also look at the silicon parameter connection, the semiconductor chip. We're going also to produce with the Taiwan company, Arthur Chow, and he will be here again next week. That's our estimated impact downstream industry on Indonesian GDP per capita in the next decade. I mentioned to you earlier with the average growth of 5.8%. We believe by 2030, our income per capita around $10,000 US. And I believe in Jakarta, maybe can go 20, 30,000, but depend on how do we manage this country for the next 10 years. So that's, I think, very important message also to our friends in the ITB. If we want to see this country become like this, we have to work together as a team and approach holistically. That's, I think, very important. We try to compare it to China GDP per capita, and I think 1 decade, they are able also to achieve this one with the average growth 7.2%. And again, ladies and gentlemen, I believe our average growth target, this is going to be around above 5.8% with the efficiency in our country. Economic transformation, improving efficiency through digitalization. This is right now ongoing, ladies and gentlemen. I just launched the Simbara. This is also digitalize all the mineral, and this could make a lot of efficiency in this country. This is also the e-government, e-procurement. This is also 400 trillion rupiah a year that have to go through the e-catalog. So then the system that we established, the government, local government, kabupaten, wali kota, provinsi, they have to buy this product. Meaning this is very important for the ITB, because we need the technology to help our SME to establish their own industry and then list to the e-catalog. So that's, I think, make Indonesia different in the future. And the BPS also discussed with this one, and we can increase our economic growth like 1.71%. So the 400 trillion rupiah, this is our own money, we can invest domestically. Now, information system for mineral and coal Simbara, I mentioned to you earlier, just launched this morning, and this one also make country become more efficient. That's also part of the ITB. So I like ITB also to share your technology, your people, to help make this country become better. Improve for efficiency through the port integration. This is also ongoing. We have 10 big seaport. We don't want to be just send our container to Singapore. We go to direct call, so then we can reduce costs. Yeah, we just reduce costs like 30%. So we plan right now Belawan and Jakarta and Surabaya and Makassar and some other 10 seaport in Indonesia, Batam, direct call. So we don't want just to be, to send our container to Singapore and direct call from Singapore. We like to do it direct call from Indonesia. That's make Indonesia become more efficient. So efficiency through digitalization, that's, I think, our target in the next 5 years. Investment in data center and submarine cable will support Indonesian growing digital economy. This is, I think, the next slide, very important for us. And we are doing this one, and we discussed it yesterday with Suhail. Our data center right now only 100 megawatt. We'll have to target 1 gigawatt, and maybe we can go up to the 2 gigawatt, because the size of Indonesia needs a big data like that. Now, economic transformation towards sustainable and green economy, green infrastructures. That's, I think, my topic that you asked me, but I have to give you the background so you understand where we are today. Yesterday, I briefed also Tony Blair about this, and he was so shocked, so impressed about what happened in Indonesia. And that's also part of my briefing to the Muhammad bin Salman, the Crown Prince, that he was also so impressed about what you are doing here. And then immediately he said, I'm going to invest very much in Indonesia. Indonesia impressive socio-economic development over the past 2 decades also has detrimental negative impacts on the environment. I think you are very aware about this. That's on the slide. The 8 years in 8th rank, Indonesia has the largest emitters of greenhouse gases. and global carbon atlas, and CO2 emission per capita is attributed to urban areas, and solid waste producer annual. This time we are moving this one. We are working on this. I promise you, I'd like you to invite you to visit. How do we make like Bali as a pilot project, for instance? Before G20, I promise you Bali make it very clean because we have the waste system very good over there. Now, Indonesia climate commitment. This is also, ladies and gentlemen, very important to understand. National Determined Contribution, NDC, in 2016, reduction of GHG emission by 2030. Now, the issue right now, ladies and gentlemen, because I've been so many conferences, developed country, basically, they just, sorry to say, I've talked very blunt, straightforward, they're just talking $1 trillion here and there, but nothing happened. So the president already committed during the G20, we're going to announce 300 to 400 megawatt of energy transition mechanism that we're going to replace and by Indonesian finance. So that's, I think, our commitment to show to the international that we are not, although we are, our GDP only $1.1 trillion today, but compared to the country might be 20 trillion GDP, but we contributed concretely to the system very well. Why green infrastructure reason and needs? This, I think, the reason, I think you can read here, need for investment in green solid waste management that we are doing today, investment in green water and waste water management, investment in green urban public transportation. And example, technology intervention, the waste management, now it happened in Indonesia. Next slide. If you look at now RDF plant in Cilacap, this is, I think, we can go up to 300 tons per day. Now existing 120, so you can see now Cilacap much better than before. This is also waste to energy Benowo, Jawa Timur, installed 12 megawatt capacity, total waste 1,000 ton per day. Then this also waste to energy Putra Cempo Solo, there's also capacity 500 tons per day. Ladies and gentlemen, also our fellows, our friends in ITB, that we have to do it. Now all this, I push them. We have to make it local content. Why should import? You have to be proud to be Indonesian. We are very smart. We can do it. And I'm very confident on that. Now, example, source-based waste management. This is also TPS 3R, TPS-T, Sarbat Gita Bali. That's now in Bali. I went in Bali last week. I pushed them to finalize this by July this year. And then we'll see that by G20, I think garbage no more, much less in Bali. Example 3, integrated Citarum waste water management, West Java. This is, I think, we clean up right now. So we are not talking. We are executing. That's, I think, the issue. Although maybe not as good as people expected, but we are much better than before. I'll show you this one. I think ITB in Bandung, you can have a look this one. I'm going to visit this again on the 16th this month to have a look. What's the progress of this? Because we promised within 7 years to have to clean Citarum. Example 4, Bandung Metropolitan Urban Railways, West Java. This is also part of our program, Mass Rapid Transit System. And then example 3, Green Port. I mentioned to you earlier, Green Port. That's also very important. We have 10 or 11 green port in Indonesia. This Lamongan container, Pupuk, Kaltim, etc. That we're going to move this very quick. So every seaport, if we can grow a mangrove, we have to grow mangrove over there. Like Patimban, I asked them to have to grow mangrove over there because mangrove can contribute 4 to 5 times to catch the carbon. Ladies and gentlemen, conclusion of my very quick presentation in overcoming the COVID-19 pandemic, Indonesia has shown that we can solve the most complex problem as long as we work together and use science, technology, and data as the basis of our policy. We are not talking about the dislike here, but we are using this one. Young people in my office, about 20 of them, they're working based on the data and they work with heart, which is, I think, very important. If we want to see this country become the developed country, we have to do it. In the past 8 years, Indonesia has transformed its economy to be more efficient, more industrialized, and less dependent on commodities. This is achieved through downstream industry, increasing efficiency through digitalization, and improving the quality of our human capital. Number three, post-pandemic, we are facing a bigger challenge in climate change. Indonesia is committed in focusing our policy on climate change emission reduction, including building the green infrastructures. Number four, to achieve our vision, becoming a developed country by 2040, Indonesia will continue implementing structural reform policies to increase the overall productivity of the economy, including human resources development, R&D and development, infrastructure development, and improving the investment climate. So, ladies and gentlemen, that's my very quick presentation. I hope that you can get some picture what happened in Indonesia today, and I believe Indonesia can contribute along. And again, I believe, sorry to say, if I talking very straightforward, I don't believe any developed country want to see the developing country become developed country. So you have to do it by your own. So to all of you and ITB, you have to work very hard to make this country become a developed country. If you don't do this one, nobody can help you. Thank you very much.
Thank you very much, Luhut, for very enthusiastic and very encouraging for us here. And then you already share with us all the policy initiative to make Indonesia as a bigger country for 2025. It's a very holistic policy that you have done. We would like to thank you. And then I believe that we are really ready to work together. ITB really work together to implement all these initiatives regarding green energy, green policy, green economy, green ports. I think this will encourage for the young people to work together to make this country great. And I believe what you have said, that we have the one to build our own country. You know, we have to rely to our own capability. I would like to ask to the audience to give a big applause to the Coordinating Minister, His Excellency Luhut Binsar Panjaitan. Thank you very much, Pak Luhut. I really appreciate that you come to this meeting and giving all the opportunity to us for your tight schedule. Thank you very much. And Mita,
thank you, Prof. Indra, and thank you to all of you. And hope this could share something what's going on right now within the government. We are doing a lot, and I believe with the support of the young generation in ITB, I think we can make Indonesia much better in the future. We have to work with heart, and we have to work with the team. So team, holistic approach, that's the way we can solve the problem in this country. Again, thank you very much, and see you soon.
Thank you very much. Thank you. Mita, saya berikan kembali, I give you the back to your.
Thank you very much, Mr. Luhut Binsar Panjaitan, MPA, and Professor Insinyur Indrajati, MSc, PhD, for your insights, as well as for your giving your precious time in the middle of your busy schedule to give your very precious insights as well. We hope the best for Indonesia. Okay, ladies and gentlemen, we would like to deliver our sincere gratitude to all keynote speakers of the first day plenary session of the 4th International Conference on Sustainable Infrastructure and Built Environment 2022. Hopefully we can take some of the key takeaways and now identify challenges more accurately to solve current and upcoming issues to build more sustainable infrastructure and a resilient built environment. Now that was the end of our plenary session for today. After this, we will continue the agenda with a 5-minute coffee break. We will also facilitate you with the breakout room to be able to interact with one another. Ladies and gentlemen, let me remind you that the first parallel paper presentation session will begin after our coffee break. You may find that there are links to the rooms of your choice in the program book. You may now download the program book provided by the committee via the Zoom chat tab. And we would also like to inform you that for the second room, or room 2 in the first session, we will have a presentation from an invited speaker, which is Mr. Abdul Malik Sadat Idris STMN, Director of Water and Irrigation from the Ministry of National Development and Planning, Republic of Indonesia. And we would like to inform you that this presentation will be held after all the presenters have presented their papers. Okay, ladies and gentlemen, if there are any difficulties, you may ask the committee in the chat tab. I wish all presenters and participants the best of luck. Ladies and gentlemen, we would like to inform you that the second day of the international conference will be held tomorrow, Wednesday, 9th March 2022 at 8 a.m. Western Indonesian time. We will be joined with our honorable keynote speakers, Dr. Insinyur M. Basuki Hadi Mulyono, MSc, Minister of Public Works and Public Housing, and Dr. Fuad Bendimerat, Executive Director of Earthquake Megacity Initiative, during the plenary session. Following the plenary session, we will have our excellent presenters and participants in the 4th and 5th parallel paper presentation session. Ladies and gentlemen, once again, thank you very much to all His Excellencies, keynote speakers, presenters, guest speakers, participants, and all of the hardworking committee. Thank you for your participation in the plenary session. We hope to see you at 5 more minutes to continue with our most anticipated agenda, the first parallel paper presentation session. I will now close the plenary session of the first day of the 4th International Conference on Sustainable Infrastructure and Built Environment 2022. I look forward to meeting you again on the second day of the conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.